In this video, we'll talk about molecule polarity. So we have right here a little animation, and we can set the electronegativities of these two atoms. So if they're completely the same, the kind of graphic I have up here is supposed to be representing the electron density, and with the color showing you how what the density is. Now, as I make atom B more and more electronegative, you can see that the color will start to get more and more uneven, right? And all the way up here, it's very noticeable, but it's a little more subtle down here. And again, you can see this arrow, and this arrow is showing you the positive end here, slightly positive, and the slightly negative end here. You can see that here as well, with the arrow pointing to the more electronegative atom. Now, something that we haven't talked about, so we've talked about the bond, so this would be a a somewhat polar bond. It might not be drastically polar, but there's definitely some unevenness here. And again, we can see this up here, kind of on this spectrum from more covalent, like more even, to less even. We can see that the larger the difference in the electronegativity, the more ionic, and the lower the difference, the more covalent. Now, what we haven't talked about is the polarity of the molecule itself. So we talked about the bond. How polar is the bond? Remember, polar just means how uneven it is. It's a separation of charge. One thing is slightly positive, one thing is slightly negative. That's what polar means. So we can say that there's a polar bond, or the bond is somewhat polar, but is the molecule polar? So let's go over to some real molecules. So this is hydrogen fluoride, and down here you can see their electronegativities. So this is going to be a very large difference in electronegativity. So if we want to look at the partial charges, let's look at the bond dipole first. So within this molecule, you can see that there is an arrow going towards the fluorine because it's more electronegative. And we can look at the electron density again. It's kind of drastic. Now if I want to look at the molecular dipole, right, this is just saying, is it polar? Let's take this away, and you're left with an arrow that has this end, this fluorine end, being the negative end, and this hydrogen being the positive end. And that makes sense, right? The fluorine's a little bit negative and the hydrogen's a little bit positive, so we can say that this molecule as a whole, because those are the only two things in it, is in fact polar. It's a polar molecule. It's got a positive end and a negative end. Let's look at water. So water, again, the difference between hydrogen and oxygen is fairly high. So within that bond, you'll see that this oxygen will be slightly negative and these hydrogens will be slightly positive. The arrows will both point from the hydrogen to the oxygen. Now, if I say, is there a negative end and a positive end of this molecule? Yes, there is. Right? And again, because this oxygen is going to be slightly negative, and this hydrogen is slightly positive. So this end, the oxygen end, is going to be negative, and then down here, the hydrogen end will be positive. How about ammonia? No, let's not do ammonia, actually. How about methane? No. Here we go. Okay. So this is carbon tetrafluoromethane, and you see it's carbon. It's got 4 fluorines, and the difference between carbon and fluorine is pretty noticeable. And so you see that these arrows will go from the carbon to the fluorine for each one, making this carbon slightly positive and each fluorine slightly negative. Right? Now, if I want to know what's the molecular dipole, is there a positive and a negative end? There isn't. Why not? Well, I can't say that one part or one end of this molecule is negative or positive, because everything on the outside, all the fluorines, all have the same kind of partial negative charge. So regardless of the way that I kind of encounter or walk up to this molecule, I'll always get the same sense of the charge. So it's actually has polar bonds, but it's a non-polar molecule.